Hey there, Professor B. What you reading there?
I am reading Moral Choices.
Oh,
Trying to,
you on the right track?
yeah,
I
basically.
hear you. Amen.
Sorry, brother. Anyway, so, where's Master Chemist?
You haven't heard the news?
He didn't come in today, no, why?
Well, I just got back from checking in on him. He's in the hospital.
Is that why you're wearing the mask?
Yeah, he seems to have contracted some respiratory disease. We don't really know what yet. I mean,
Is he coughing profusely?
yeah, quite a bit. That's why I'm wearing a face mask here.
Do you think I should be wearing a face mask? Am I at risk?
I don't know.
What?
You're good. You're good. Don't worry.
What are you talking about? If this is a serious,
You got this. Look, he's gonna be out for a few weeks. A couple pull-ups, maybe. I don't know.
weeks?
I,
Months?
I can't say yet. We don't know. Chemistry for kids. You got this.
Right, guys. So I guess this is just going to be a solo Boron episode. I'm going to talk about electron configuration without the Master Chemist. Darn. Gosh darn it.
It is a fascinating journey, this path of knowledge, and the vehicle we ride is a science called chemistry.
Here we go.
Oh, hi. I didn't see you there. Well, as I said before, we're going to talk about electron configuration. I think this will be a short video, relatively, but I think it'll be nice just as a way of understanding in context of the periodic table and notating which we'll get into later. Yeah. You're still wearing a mask. You're sure I shouldn't be wearing one?
Yeah, I'm sure. You're good.
Really? Really?
When was the last time you saw him?
I don't know, like 2 days ago?
Maybe he got it. Maybe he contracted it a day ago. You're good.
Okay. Anyway, so we're gonna continue. Okay, so this diagram, what it's supposed to show is just so the numbers represents the different energy levels, and it is important to note that especially with the S and the P categories, that they operate with the rows. So the first row would be the first energy level, the second row would be the second, so on and so forth. It does diverge from that when it comes to the D and the F. D, you could just think of it as it starts from 3, so then it just increases 3, 4, 5. So even though it's on the 4th row, since that would be the first of the D interval, it would then just start at 3. And same thing with F, it just starts at 4 when you're talking about the first row for the F interval, right? Just going on into notation. So typically most don't actually use electron notation, honestly, because there's not really a use for it. Most people just state the element, but it's a good way of really having a comprehensive look at just how these electrons operate in relation to the atom. So here we have selenium, right? So how you would notate this in just normal fashion, you would just go in order of the different orbitals, the different sublevels. So we would start with 1s, and then 2s, and 2p, then 3s, 3p, 4s, and so on, right? So you might be wondering, what the heck are these exponents here, if you can see? The 2 and the 6, that's weird. So I think, just as a background, just so you understand better, is the different sublevels have a different number of orbitals in them, and each contain 2 electrons. So the S sublevel has just 1 orbital, which fits 2 electrons. That's why there's a 2 for the exponent. For P, it has 3 orbitals, but each orbital contains 2 electrons, so that's why it's 6. D has 5 orbitals, each with 2 electrons, and so that has an exponent of 10, and that just represents the number of electrons that are total within that sublevel. So as you just progress and you get to the last one, that completes the entire notation. But there is a more efficient way of handling it, which is just using the noble gases as a way of better coordinating. So you don't have to write all this out. So what you do is you would just write the most recent noble gas that comes up before selenium, and that would be argon. So then you would just start at argon, and then you just progress from 4s, 3d, and then 4p. That's what you would do. Also, another way is just drawing it out, such as this, as a better visual for the electrons and the different spins that they have within the orbitals. So for 1s, again, as I already described, there's just one orbital, but then it contains the 2 electrons within it. And then of course with 2p over here, the 3 orbitals, as better visually represented here with the different 2 electrons. So another thing that would be important to note is the principles in which this acts in. So first, I think the most important one I'd like to talk about would be the Aufbau principle. So that essentially states that electrons fill the most stable energy levels, or the levels that are at the least amount of energy. So in this instance, you would start with just 1s. That would be the very first one because it has the lowest energy out of all. The next one would be the Pauli exclusion principle, and that operates with stating that the orbitals not only can each only contain 2 electrons, but none of them can have electrons that go in the same direction. So in each orbital, they have to go in opposing directions because otherwise they cannot. It better facilitates a spin. Right. And then so the next, the very last one would be Kuhn's principle. There's a lot of Germans here. I don't know how to feel about that. That's just how it is. But so when you're using this type of notation, what you would do is you would first, I guess when you're, because here it's filled, so you don't really get a better way of looking at it. But as you can see with the 3s, it's not fully complete. So how you would first start out is just with the first electron spinning upward, and then the next one downward. But with the 2p, let's say, I don't know, I'm just gonna change it up a bit. But instead, it had 5 electrons. So how you would then go on writing this would be, of course, with the 3 orbitals. But then what you would do is you would first fill each orbital with an upward spinning electron. So this is how you would draw it out first of all. And then you would go on to fill the rest with a negatively spinning electron. But then since there's 5, this one would be empty. But that's how you would conclude in actually drawing that, so you can have a better visual representation of just electrons and how they act within atoms. You know, I don't know, it's kind of sad these days because I feel like I'm a bit off my game without Master Chemist here. He's a really good support figure for matters like these. But you really appreciate people like that when they're not here. Am I right?
Amen.
Like there's a sense of just emptiness without him, right? Like I feel like I should be able to, like, there should be something there, but you know, he's not here today, so it's unfortunate. Anyway, so I think we're gonna conclude the video there. Thanks for watching. Look forward to comments. We're gonna read comments soon. Next up, but I'd like to end with an outro and say bye. You know, this is a lot of viewer submitted questions. I don't know how we're gonna get through all this, especially with it's just me. I don't know how I'm gonna do that. Darn.
You know what I've been through. Oh, I'm so glad to see you.
Master Chemist?
Yeah, it's me.
I could barely recognize you with that mask on.
Oh, I had to. I was in the hospital for at least 2 weeks. They found this weird kind of virus, mesothelioma. I think you've heard of it before.
Virus?
I don't know, virus, cancer, whatever.
You know,
bacteria. Is it
You do know what it is, right?
It's yeah.
It's a rare type of cancer. You know, you could probably get some compensation for that, because it is a rare form of cancer and it's caused by asbestos.
I was doing some home improvement and.
Oh, see, that explains it, because it's usually found in insulation, so that's probably why.
So who do I go for? Who do I go to?
I know, you know those ads, right?
Okay, but you said I can make millions, right?
I did not say that. I didn't say that.
I've seen
I
the
just said you
adverts.
can get compensation for it. That's all I said.
Oh, but I know. I've seen the advert stuff. 6 digits, 7 digits.
Okay,
that I've
okay.
seen.
You know what? You can try it.
But listen,
we'll see.
Listen, I don't need
I'll
that
send
kind
you
of
the
money.
link. I'll send you the link. It's fine.
But why would I need that kind of money? If I can make this kind of money doing Chem for Kids, there's more positives than Chem for Kids. They're getting some cheap compensation.
Are you willing to die for chemistry for kids?
Yes.
Really? Really?
Absolutely, yes. You gotta stick with the program. You can't rat yourself out. You can't take the short way out. When there's a fork in the road, you gotta take the long way, not the short way. And right now, I can't even see. So,
Oh my god.
I'm in it. So what lesson are we doing?
Today we're doing chemical bonding and reactions. So I hope that's not too much for you, right?
We're good. Let's head over now.
Alright, let's do it.